Educational Module, Statistics for Data Science, Learning Unit, Advanced Data Visualization Packages in R, ggplot2 and Plotly. ggplot2 is one of the core packages in Tidyverse, which is an opinionated collection of R packages, designed for data science. All packages in Tidyverse share an underlying design philosophy, grammar, and data structures. Tidyverse includes, along with ggplot2, the number of other core packages used in everyday data analyses, and a set of additional packages with more specialized usage. These additional packages are not loaded automatically with library Tidyverse, so you'll need to load each one with its own call to library. ggplot2 is a system for declaratively creating graphics. You provide the data, tell ggplot2 how to map variables to aesthetics, what graphical primitives to use, and it takes care of the details. The package's popularity in the R community has exploded in recent years. One reason ggplot2 is generally more intuitive for beginners is that it uses the layered grammar of graphics, hence the GG in ggplot2. This is analogous to the way learning grammar can help the beginner construct hundreds of different sentences by learning just a handful of verbs, nouns and adjectives. One limitation is that ggplot2 is designed to work exclusively with data tables in tidy format where rows, observations and columns are variables. However, a substantial percentage of datasets that beginners work with are in, or can be converted into this format. To be able to use ggplot2 you will have to learn several functions and argument names, and since memorizing them is not so easy, it is a good idea to have a ggplot2 cheat sheet nearby. The concept behind ggplot2 divides plot into three different fundamental parts. Plot equals data plus aesthetics plus geometry. Data is a data frame, could be for example a data set such as iris or empty cars, or a user-generated data frame. We refer to this as the data component. Geometry defines the type of graphics. Possible geometries are bar plot, histogram, smooth densities, plot, and box plot. Aesthetic mapping is used to indicate X and Y variables. It can also be used to control the color, the size or the shape of points, the height of bars, etc. To give you the whole picture, the grammar of graphics defines additional layers that allow us full flexibility to generating the graph. In the figure below you can see the complete set of layers we can specify for a ggplot graph. From bottom to top layers comprise data and aesthetics that we have discussed about, scale, geometric objects which is geometry statistics, facets and coordinate system. Let's see some details about each additional layer. Scale is used to determine whether we need to scale the potential values, use a specific scale to represent multiple values or a range. Statistics is useful when we need to show some statistical measures in the visualization, like measures of central tendency, spread, and confidence intervals. Facets used when we need to create subplots based on specific data dimensions. We will see an example later on. Coordinate system allows us to define the coordinate system to base the visualization, e.g. should it be Cartesian or polar. The qplot function can be used to create more easily the most common graph types, qplot from quickplot. Even though qplot does not expose the full power of ggplot2, it can create a very wide range of useful plots. The general syntax is the one you see on this slide. Let us go through possible arguments and their meaning. X and Y specifies the variables placed on the horizontal and vertical axis. For univariate plots, for example, histograms omit Y data. Specifies a data frame. If not specified, will create one, extracting vectors from the current environment. Color, shape, size, film associates the levels of variable with symbol color, shape, or size. For line plots, color associates levels of a variable with line color. For density and box plots, fill associates fill colors with a variable. Legends are drawn automatically. Alpha Alpha transparency for overlapping elements expressed as a fraction between 0 complete transparency and 1 complete opacity. Facets. With facetting, you can make multi-panel plots and control how the scales of one panel relate to the scales of another. Pix facet_wrap or facet_grip depending on whether the formula is one- or two-sided. Its value is expressed as row tilde colbar. Geometry specifies the geometric objects that define the graph type. The geometry option is expressed as a character vector with one or more entries. Geometry values include point smooth box plot line histogram density bar and jitter. Main, sub, character vectors specifying the title and subtitle. Method, formula. If geometry equals smooth, the lowest fit line and confidence limits are added by default. When the number of observations is greater than 1000, a more efficient smoothing algorithm is employed. Methods include LHAM for regression, GAM for generalized additive models, and RLHAM for robust regression. The formula parameter gives the form of the fit. Note that the formula uses the letters X and Y, not the names of the variables. For method equals GAM, be sure to load the MGCB package. For method equals IML, load the MAS package. XLab, YLab. Character vectors specifying horizontal and vertical axis labels. Xlimeric, Ymeric. Two-element numeric vectors giving the minimum and maximum values for the horizontal and vertical axes, respectively. Note that you can use the I value to indicate a specific value for the respective argument. Let's see some examples of generating graphs using the qplot function. To experiment with the ggplot to package functions and arguments, we will be using our preloaded datasets. Remember, we have already used the iris and mtcars datasets. We can list all preloaded datasets with the command data. For more information on a particular dataset, use the help command. Example, $mtcars or help mtcars, for help on the mtcars dataset. Back to our qplot function now. It is important to know that if we call the qplot function with just one argument qplot x, our guess is that we want to make a histogram. When we provide two arguments, it produces a scatter plot. We start by loading the ggplot to library ggplot2. Then we execute qplot iris $petal.length. And we get the graph on the right. The graph shows the values of petal length for all recorded species in the data set on x-axis. Y-axis shows the number of occurrences of specific petal length. If we give two arguments to the qplot function, R generates a scatter plot. In this example, we executed qplot iris $petal.length, iris $width. The generated graph is scatter plot in the right. The graph shows petal length on x-axis versus sepal width on y-axis. Thus each dot represents a pair of values. Now let's see another example. This time we will use the mtcars dataset. In this dataset we alter the column gear and change it into factor type with 3 levels as it was and labels 3 gears, 4 gears and 5 gears. We then print the first 6 lines of mtcars just to make sure that our change was applied. Next, we call the qplot function using the values of column HP in the mtcars dataset using the density geometry applied for each factor level in column gear. We also apply transparency in the alpha argument, provide a title for the graph and labels for the two axes. On the right we see the produced graph. Color coding based on gear is determined by the fill argument and the legend is drawn automatically. In this example we produce a box plot, actually one box plot for each factor level in the data set. Axis Y depicts horsepower. The applied geometry is box plot color coding and legend is determined by the fill argument, and in this case we give an empty label to axis X, and specific label to axis Y and an overall title to the graph. On the right we see the produced box plots with jitter. While qplot is easy to use for simple graphs, it does not exploit the powerful grammar of graphics. The ggplot function does that. ggplot starts by calling the aesthetic. For one variable, the syntax is the one depicted in blue on the slide. Here, we declare that there is only one variable, and is placed along the horizontal x-axis. For two variables, the syntax is slightly altered. You can see it again in blue. In this case, we declare that there are two variables, one for the horizontal x-axis, and another for the vertical y-axis, in the aesthetic. Note that we have assigned our plot to a variable named p, so that we can use it later on, when we may want to add other features to plot p. This iterative nature of ggplot2 is one of the things that makes it so powerful. After the aesthetic, we declare the geometry. We can then add different geometries to our plot. For one variable, we can choose among the following: geometry underscore dot plot. This says add the dot plot geometry to the graph. Geometry underscore histogram. This says add a histogram geometry to the graph. Geometry underscore violin. This says add a violin plot geometry to the graph. If we use two variables, we can choose from the following: geometry underscore point. This says add a point scatter plot geometry to the graph. Geometry underscore smooth. This says add a smoother to the graph. You can find more details about all ggplot supported functions and arguments at the official ggplot2 website at https://ggplot2.tidyverse.org/reference. Let's start by creating the bar plot with the ggplot2 library functions. To do this, we will need the geometry underscore bar function and will experiment with some simple customizations as well. This is the most basic bar plot you can build using the ggplot2 package. It follows those steps. 1. Decide the data we will represent on the bar chart. Remember, they have to be in the form of a data frame. In this example, we will create our data using trivial concatenation function C. 2. Call the ggplot function. 3. Specify the data object. It has to be a data frame, and it needs one numeric and one categorical variable. 4. Define aesthetics. Set in the ease function. Set the categorical variable for the x-axis. Use a numeric for the y-axis. 5. Finally, call geometry underscore bar. Note that the default value of the argument stat is bin, which means that the height of the bar represents how many times a value appears. By using identity, we make our display the values and not the count of values. In the example below, we first create the data to be passed to the ggplot function, and then we create the bar chart using the ggplot function. The data we generate is in the form of a data frame and includes working weekdays categorical values and number of views numeric values. We call the ggplot function with the data frame as the first argument. Then we define the aesthetics to be days on the horizontal axis and views on the vertical. For geometry, we pass as type of plot the bar chart, and we also define that we do not want the default value for the stat argument, but we want to see actual number of views, so we use identity. To the previous bar plot, we can define additional customization options. This is the power of ggplot. Here we start with the name of the plot we have generated so far, my plot, and then we add a specification about flipping OTS coordinates. This is done by calling the function coord underscore flip. Then we add a title to the plot using the statement lab function with the title text as value to argument title. We can create a histogram by adding to ggplot a layer with the geometry underscore histogram function. This function automatically cuts the variable in bins and counts the number of data points per bin. You can try different bin sizes using the bin width argument. In some cases, R will return a warning about the size of the bin but will generate the histogram anyway. Usually in this case, you have to decrease the default bin size by setting a lower value to the bin width argument. In this example, we first recall the iris dataset by accessing its first 6 rows of data. Then, we create a histogram depicting petal length values on x-axis and count of values on the y-axis. Next, we choose to color the graph according to the species column of the dataset. The legend is generated automatically. We can add the title to the plot and labels on the two axes by passing the respective values to function ggtitle for the main plot title and labs for the axes labels. See how this can be done in the bold part of the R code on this slide. The new, enriched version of the histogram is shown on the slide. A scatter plot displays the values of two variables along two axes. It shows the relationship between them, eventually revealing a correlation. We will create a scatter plot to show the relationship between petal width and petal length of plants recorded in the iris dataset. In this first example, we call the ggplot function for data in the iris dataset with aesthetics comprising petal length on the horizontal axis and petal width on the vertical. Also, we define geometry of points, thus a scatter plot by calling function geometry_point. On this second example, we add the parts in red to the previous plot. More specifically, we add the specification that we want to use the values in species column of the data set. Remember, it is a categorical value to determine dot color. This automatically generates the legend information in the right. We also increase the size of each dot by setting size equals 2 in the geometry_point function, and add a layer with geometry_smooth function. This generates regression lines and confidence limits for each point group, thus for each species. The box plot summarizes the distribution of a continuous variable. Different color scales can be applied to it, and this post describes how to do so using the ggplot2 library. In this example, we generate a plot using data from the MPG dataset. In the aesthetics, we define to display values from column class on the horizontal axis, and values from column highway mileage, in miles per gallon on the vertical. We also apply transparency 0.5. We remove the legend, and use a predefined color palette. The fact that we want to generate a box plot for all data points that belong to the same car class is determined by passing to argument fill the value class. We can even generate multiple plots using facets. Faceting is useful in circumstances where we want to plot relationships between set variables in multiple subsets of the data, with the results appearing as panels in a larger figure. It is a very useful feature of ggplot2. The faceting is defined by a categorical variable or variables. Each panel plot corresponds to a set value of the variable. Let's see, for example, how we can extend the previous statement to produce multiple box plots, one for each style value in our dataset, i.e. number of cylinders. As you can see, we first assign out initially generated plot a name, let's say Q, so that we can use this name and add to it additional layers, meaning customization. Then, call the name of the plot and use plus to add to it a call to the facet_wrap function. This function takes as input the cylinder column and generates for each group of data points with the same cylinder value a separate plot. See the resettling set of plots on the slide. Plotly is an R package for creating interactive web-based graphs via the open-source Plotly.js JavaScript graphing library. There are two main ways to creating a Plotly object, either by transforming the ggplot2 object into a Plotly object using the ggplotly function, or by directly initializing a Plotly object using either plot_ly, plot_geo, or plot_mapbox. Both approaches have complementary strengths and weaknesses, so it is better to see both approaches. Moreover, both approaches are an implementation of the grammar of graphics. You can install Plotly using the typical package installation procedure in our install.packages Plotly. And then we load it into our current R session using the library Plotly. By default, Plotly for R runs locally in your web browser or in the RStudio viewer. We start with the first approach. So, If we already work with ggplot2plots, the Plotly package can easily convert any static ggplot2 plot to an interactive web-based version, using the ggplotly function. Let's see an example. Here, we start by creating the subset of the Diamonds dataset. Diamonds is a Boolean dataset just like mTrCars and Iris. We do a little exploration by calling head diamonds to see columns in the data set and the first 6 rows of data. Then we call set.seed100, which is a helper function for the sample function we will call next. It makes sure each time we call the sample we will get the same random results if we keep using the same seed. The sample function we use to create our dataset takes randomly 1000 rows from the initial diamonds dataset, which contains 53,940 rows. We name our subset MidDiam and do a sum exploration as well to see the first 6 rows. Then we create a scattered plot with caret on X and price on Y. We also apply faceting using values of the cut column in the data set, which is a factor of 5 levels. Up to this point all we have done is the process we would use to create the scattered plot using ggplot. The only additional step that will transform our ggplot static scattered plot to an interactive scattered plot is the last statement, gplotly p, where p is the name of our ggplot scattered plot. So, making the ggplot graph interactive is in fact a very easy process. In the screenshot on the right, you can see the graph generated in the RStudio viewer. Plotly graphs are interactive. You click on legend entries to toggle traces, click and drag on the chart to zoom, double-click to auto-scale, shift and drag to pan. On this plot, notice the point where the mouse is positioned, where you can see a trace listing cut, caret and price values, for the specific data point. You can also publish your charts to the web with Plotly's web service, but this process is out of our scope in this module. The second approach creates from zero the plot in Plotly, without passing through ggplot. In this example, we will use the plot_ly function. Let's start by generating our data. We first define x to be a vector with the sequence 1.100. For calculating the 100 elements in vectors y1 and y2, we use vector arithmetic and a normal distribution with seed 123. In the Global Environment tab of the RStudio screenshot on the right, you can see the first elements in all vectors we have created, x, y1 and y2. Note that the %> operator is a pipe operator, which passes data from the output of the function on the left, and puts it, by default, into the first parameter of the function on the right. This is important because, as you know, R is a functional language, which means that our code often contains a lot of parentheses, and when we have complex code, this often will mean a lot of parentheses nested together. Thus our code is hard to read and understand. The pipe operator allows us to rearrange our code so that we can read a sequence of modifications from left to right rather than inside out. Back to our example now. To generate the scattered plot we call the plot_ly function first for the blue part of the plot with x values on the horizontal axis and y1 values on the vertical. Then we add to this the data points in blue with again x values on the horizontal axis and y2 values on the vertical axis. We also define that we want R to display the legend with traces at a specific place x equals 0.5 and y equals 1, and the background color for the legend is number sign F3 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 in hex format. In this unit we have discussed the ggplot2 package, which is a part of the Tidyverse package, the grammar of graphics concept and how it is used to gradually add features to any needle plot, the qplot function and arguments we can use to quickly produce a plot, the ggplot function and arguments, which offer us the full expressive power and flexibility of the grammar of graphics, and finally, the Plotly package and ways to use it to produce interactive plots for the web.